Thank you. I'm feeling like crap. I thought I was jet lag and sleep deprivation, but now I'm cold and have shivers. So afterwards, don't shake my hand. So I'm going to fake it till I make it. Okay, how many of you came because of the words, because you know what entity resolution is? Okay, and how many of you came because it had the word AI in it, and anything that's got AI in it, it's got to be amazing or fake. Okay, thought I would start by, often AI and machine learning are terms that get conflated, I think. So I just thought I'd give you my definitions. AI being systems that act smart, and machine learning systems that learn through experience. Many AIs would use machine learning, but not all. They don't have to. Now, first, a quick introduction to entity resolution. My definition being recognizing when two observations relate to the same entity despite having been described differently. If you look closely, you'll see the names are fuzzy, and the address isn't quite the same, and the phone numbers are formatted different. But same name, address, cell phone, you could lock them together, you'd think. Now, the converse is true, though, in the definition, is that recognizing when two observations do not relate to the same entity despite having been described differently. Or, excuse me, but despite having been described similarly. In this case, I've just added a JR and an SR. Now, the only difference we've introduced is an S versus a J, and you'd be more confident these are different people. Now, examples of entity resolution if you have duplicates in your address book. The first time you met them, you put their last name in as a question mark. The next time you met them, it was the full name with the Gmail account. Now you got two. That's an entity resolution problem. Companies that have prospects, they're marketing to me. They say, come, be a customer of our bank. I'm like, I'm already your customer. They didn't compare and entity resolve their prospect list to the customer list. We see this in banks. Somebody's an evil bastard. They kick them out, and then they just use a different passport and show up in India, and they're like, yay, new customer. Entity resolution problem. And watch listing systems, somebody will just change one letter in their name. This happened in the Boston bomber. The Russian, I think, came in, took one consonant out of his last name, and they just couldn't even see him. Missed the whole watch list, and that's an entity resolution problem. So entity resolution happens to be fundamental to intelligence, and not just machine and human intelligence, but otherwise. I don't know if you've seen this video on YouTube. He's called the Lion Whisperer. If I were to back this up, here's how it kind of goes. He's standing out there in Africa, and he goes, I haven't seen him in a long time, but I knew him as kids. Here, kitty, 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 or whatever he calls them. And then this line and one right behind it's rushing at him. You're like, oh, awesome. And gives him a big hug. Now, if there wasn't some entity resolution going on, it would just be a different kind of movie. So just some quick background now. That's quick intro, but quick background is I had a custom software company. I've spent my whole life designing and architecting systems. I've built about 100 over the years. I moved my company to Las Vegas in the early 90s, spent the last half of my life roughly living there. One of the systems we built was used to help bring down the MIT card count team. So if you've read the book Bringing Down the House or saw the movie 21, we had our hands in the automation behind that. We built some other software that became known as NORA, non-obvious relationship awareness. The casinos, if they get caught transacting with a regulatory, the Nevada Gaming Control Board has a regulatory exclusionary list. If you get caught transacting with them, you can lose your gaming license. And some of these clever bad guys, they have 32 different names they use. Like, hey, which one am I going to use today? Yeah, let's use this name and this social security number and my brother's date of birth. Ha! And so we set out to solve that problem. That was really the first robust entity resolution system that I built. We did 2 rounds of venture capital. IBM buys my company in 2005. I stayed 11 years. IBM renames it to Identity Insight. She's beautiful. She's my oldest daughter. I have abandoned her. Okay. And it sees a lot of business in financial services and government. But in 2009, I take all this experience that my team and I have had a few hundred years of entity resolution. I thought if you could start over, if you had a $50 million budget, what would you do? If you started from scratch, could you create something that doesn't need tuning or training? Not using AI to do it, could you build an AI just to do this? And so IBM let me set me free on this, and I spent, my team and I spent the next year on paper just to get some schema and structure right. And we spent the next year and a half building it, and it became public. We started shipping it commercially in 2012. But before I show you a few more use cases, I want to now do something I like to call entity resolution in slow motion. I spent 30 hours on these charts. So I want you to really take it in. I hope you can see this. I feel like it's a comedy show. You're going to slowly watch me die as I get sicker and sicker. You'll be like, the charts are great, but he's just slowly died. Look at those 3 records. Do you think this should become, I mean, is this all about one person? Or do you think it's like 2 different people? Or do you be like, nope, that's one person? How many of you say one person? How many of you say 2 people? How many of you say those are 3 different people? Okay, good. Let's review. It turns out, let's just look at record 1 and 3. The names, Robert and Rob, good. Address, close enough. Same cell phone, ending in 1214. Hey, same cell phone, address, name, pretty good to go. Now let's look at the middle record. Bob Smith, Robert Smith. It's got the same date of birth except the month and day are transposed. Yeah, happens all the time. And it's got the same phone number, so pretty much good to go. So this would be an example of entity resolution on fuzzy data. In comes another record, and all it has is the email address. You can't say they're the same just because of the email address. Many family members, especially in India, their whole families share the same email. So in fact, because the name is different, you have to, we call it a discovered relationship. Could have been an email, an address, or a phone. And while I'm on relationships, this is kind of freebie. It's called a disclosed relationship. Somebody told you it's the spouse on the employment application. It's the co-signer on the bank account. And so, that becomes a disclosed relationship. When you're, one of the things that banks do is there's some, they need to kind of know who owns companies, so they go to companies like Dun & Bradstreet and buy something called beneficial ownership files, and then they load hierarchies on top of companies to see who owns them. Now it gets a little more interesting with record 6. Take a look, compare it primarily to 1, and I ask you the following question. Given that information in record 1 and 6, would you be totally sure it's the same person? Or would you be like, there's a good chance, but you just can't be sure? You would need a little more information. And as you probably have guessed, you need a little more information. And so we call this a possible match. So it just hovers out there like that. This one's been very difficult. Most entity engines don't do this right. It's taken a lot of work. When record 7 shows up, where would you put it? Would you give it to record 1 or 4? Most systems will arbitrarily assign it to one or the other. Or if it had the word street on it, it would be like, it's so definitely number 1. As if Patricia didn't live on a street. Now that's bad, because if record 7 was shoot on sight, then you've just kind of 50-50 killed the wrong person. The next recommendation would be like, send the family flowers. Okay, that's a joke. Kidding. So we call this ambiguous. We hold it out. And what we do here is, if this didn't exist, you could be pretty sure it's this one. And if this didn't exist, you'd be pretty sure it's this. But there's 2 right answers. So you have to hold it out so you can not get confused and have it arbitrarily snap in. Okay, record 8 will also be a bit interesting, I think, compared to record 2. Kind of same person, pretty much. Pretty good. Now, if you put record 8 in there with 2, something else magical should happen. Anybody want to ponder that? Huh?
Record 6.
Yes. You see, when 8 snaps into this entity 1, because of the name, the phone, and the address, it learns an email address. And suddenly, this entity now has the name, the date of birth, and the email address. And so upon the arrival of 8, boom, it fixes the possible match. So far, so good? Okay. Record 9 compared to record 3. It's a tragedy. What is it?
You learned that number 3 is actually not the same as number 1 and 2?
That is correct. That's one of the fastest answers to see that. And so what happens when 9 arrives, it's not entity E1 because it's a very different date of birth, but it has the same passport as 3. 9 is going to appear here, and 3 is going to be stolen from here, and the relationship now pivots to here like that. This is a learning thing. You see, it's getting smarter while it's running. This is really expensive and difficult to do. Imagine that you've ingested 1 billion records. You made 1 billion bets about who is who and who's related to who, and now you get record 1,000,001. You have to say, where does it go? Is it new or known? And how, now that I know that, had I known that in the beginning, over the billion records, would I have made any decisions differently? Doing that at thousands of transactions a second is non-trivial. If you don't fix those, like when record 8 showed up and it fixed 6, it moved it in, or 9 showed up and pulled 3 out, if you don't fix those, your database starts drifting from the truth. You've got the truth. Some organizations I hear, it drifts at 1% a month. So every quarter they tear it down and reload it to fix it. And then they tear it down and reload it. These systems are unstable. It means for 90 days you might have had the right answer, but you're making the wrong decision. I refer to this as sequence neutrality. Did you get record A first, then B, then C? Or did you get record C first, then B, then A? Once you've seen all three, you should have the same answer. You shouldn't have to wait till the end of a month or a quarter or the end of the year and reload. So if you have a sequence neutral system, the percent of error, my green line, is slowly sloping down because it's fixing itself as it goes. Hard to do. Okay, a few more. This took 3 hours. I'll show you again if you missed it. Noodle record 10, you will notice that it doesn't have enough to match in record 1, just an address. And it doesn't have enough to match with record 2 or 3 or any of them. Most entity resolution systems are doing record matching. It can't match anything because it doesn't match any of the records. By the way, in the work in entity resolution we do, like, helps with marketing and healthcare and this and that, but some of the greatest fun my team and I have is catching evil people. And it turns out, if you do record matching, you can't catch evil people because evil people who are clever don't use the same name, address, and passport and date of birth on every record. Only the idiots would do that. And they run out of gas on the way to the operation. They take a web match to a fuse. It's all very self-correcting. And so this is entity-centric learning. What's happening inside of E1 is it's remembering every name variation, even misspellings or AKAs. It's remembering every address and phone number. If there have been 7 dates of birth, why would you throw any of them away? Why didn't you just remember those? And it turns out to be very key to catching clever bad people. Now, I refer to this as channel separation. It's the single most primary tradecraft. I've seen this hold true from, they're not really criminals at all. Card counters are just opportunists. They're using their mind to beat the game. But in every domain I've seen, I was a late bloomer to this, I realized channel separation is the primary tradecraft. And if you, oh, by the way, you and I do this too. I mean, really. If I were to send you an encrypted document and then call you with the password, that's channel separation. So the trick is to do that, channel consolidate. And inside of entity resolution, the sub-technique that's needed is entity-centric learning. Now I have a real example for you from a, let's see how this looks. Okay, that's what's going to happen. I don't know if you can see this. I'll tell you a little about it. This is a big global bank, but we've changed the names and the details to protect the innocent, but it's the precise example. I want you to imagine they have 5 customers, but the bank doesn't know it's all the same customer. Customer 1 was in Hong Kong, and they figured out they were a money launderer, and they got rid of them. Ejected them out of the bank. But they had no idea that customer, by the way, they already had the customer 4 other times, and then after he got kicked out of the bank in Hong Kong, still he's with the bank 3 times, he shows up in India with an India passport and a slight difference to the name, a letter or 2, and they're like, yay, great customer. And if you were to compare this and that, the only thing similar is just the name, and the other name's got like no spaces in it. Praveen V. Gupta, and this one's got no space. If you're just matching names between customer files and 800 million identity records, you can't even see this. There's too many people with the same name. How would they ever know? What happens is, with entity resolution, it figures out customer 2 and 3 are the same because of the name in this passport. So those 2 records conjoin and become one. And these 2 records become one because of the name, date of birth, and this tax ID. So you have 2 entities now, this one and that one. But now because you have all of these features, and here because you have all of those features, it resolves them all and goes, aha! But now it learns all those features, all the passports, all the name variations. And once you realize customers 2, 3, 4, 5 are all the same customer with the union of all those features, you can make this. Ta-da. Okay. I think only one more move. GDPR. Somebody gives you a right to be forgotten, and it's a kind of record you can't delete. I mean, you can't delete like, hey, delete my dad. I don't owe you any money. Delete it. Well, they don't have to delete that. But if it's some other kinds of records, they need to delete it. But when we added 8, it was the inspiration to pull in 6, the possible. And it was one of the reasons why 10 landed in there, because of the entity centric. So if you delete 8 in real time, it has to pull out and change the past, because otherwise, how are you going to explain it to somebody about why 6 and 1 were together? There's no evidence. We've done a lot of work in multicultural names, so you can do scripts and transliteration. Just the name comparison function in entity resolution is super involved. Our name comparison function that we use is an IBM thing called global name recognition, but it's been trained on 800 million names. And so the way Mohammed is spelled in Arabic is one way, but the way it's transliterated in English is there's dozens, and then it's spelled different ways in France versus the Philippines. And all of those transliterations across lots of languages are covered by culture. And then it's also culturally aware. If the name is Arabic in nature, then bin and Hajj aren't part of the name. It's son of and somebody that went to the Hajj. So just comparing names is a multi-million-dollar challenge. The entity resolution that we've been doing not only will work on people, but vessels. We've done some work with the Singaporeans. Company data. I might demo that in a minute. Oh yeah, good, and I hit a chart. I put a few hours into this deck. It's like one of a kind. I'm not even sure what comes next. Anyway, I now realize what comes next. I wanted to take you back and give you some examples, but this is the early example from Las Vegas. They had 18 different watch lists, kind of the red buckets. Some are super bad. By the way, self-exclusionary list isn't super bad. These are people that are gambling addicted. And this is the only watch list I know of where you can add yourself to it but cannot take yourself off. Right? You had a couple of tequilas, you're like, I'm pretty lucky actually. So you just like delete your name. It's kind of weird, right? Get your name on a watch list. I was just kidding. In Singapore, they can put their family members on it. So they took all these good guy data and then all the bad guy data and put it all in one bucket. And this NORA thing figures out who's who and who's related to who. And I found my original report with summary numbers I'm going to share with you. It's like 100 years ago. I don't know if you can read it. We found 21 active players were known cheaters. The funny thing about this is I was briefing the head of security, and I'm showing them a report, and one of the players that's a cheater, he goes, we just bought them a plane ticket to come back in 2 weeks. Are you telling me we're paying the cheaters to come? I'm like, ah! 23 players had relationships to people they'd already arrested. Bad. 12 employees were the player at that time. It was against policy on the strip casinos to be a player and an employee. You could do it on the off-strip casinos. 192 employees related to vendors, and 7 employees that didn't know the vendor. They were the vendor. NORA grows up, becomes this beautiful thing called identity inside that I abandoned. But a couple of great examples of that I dusted off for this deck is the Social Service Agency, Alameda County. They used to spend 90 days to give people the services they needed because they'd have to go search a bunch of different databases and pull it together to find out their entitlements. And so entity resolution brought all that together so they give people services exactly the same day, right when they needed it. Usually when you open up the pipe that much, you get an increase in fraud. Their fraud dropped so significantly, paid for its whole self in 2 months. Another one I'm very proud of is MoneyGram turns on that earlier engine of mine. Their fraud complaints dropped 72% the next day. And if you were to read this case study, it's got this great story about a grandma. Might creep you out as kind of an AI story because the machine argues with the humans and then wins. But here's how it goes. Grandma goes to MoneyGram to transfer, I think it was $2,500. I'd have to look again. And MoneyGram's machine goes, nah, that's probably not a good idea. Because it did some entity resolution and compared it to other people it's seen and problematic recipients and so on. And so they call Grandma, 100-plus-year-old, and go, hey, fraud. She goes, no, I've talked to him. This is my time of need. You need to transfer it. They're looking at the answer from this. They go, no. She's furious, but they don't transfer it. And it would have been her loss. She calls back 3 days later in tears and goes, it was fraud, thank you. That's like a great story. Long live AI. Okay. Anybody have a question on that? I'm feeling kind of weak. This is your time to take me down. Okay. So that identity insight thing grows up, and then I work on this G2 next generation of technology. And just a couple of more examples of entity resolution from this class. When we started in 2012, they only had 5 states, but this story was just broke in the New York Times on Election Day in the U.S. a month ago. And half the country's voter registration runs on it. This is voter data and Department of Motor Vehicle data and deceased persons data. It has 300 million records. Their entire computer department is run by one person. And they give recommendations to states, and both blue states, Democratic and Republican states, all are gaining benefit from it. And it's recently, I've been told it was like the biggest voter registration drive in the history of America. So my team and I were all like, woohoo! Another use of, an early use of G2 is it was used in Colombia to find 600,000 fake students and save them 300 million. And I worked on this project also personally, as well as the Eric one, but we've helped the Singaporeans. The Malacca Straits are right here. This is Singapore's a little dot there, and then in between here is the Malacca Straits. Half the world's oil supply, a third of the world's commodities go through there. And the Singaporeans are trying to figure out on any given day which vessel is the most interesting. And so crew data, vessel ownership data, hierarchies of ownership data for vessels. Is it the same vessel that's over there? So entity resolving vessels. Geospatial data about where vessels go and how long they hang out. And all of that stuff woven together. And it produces a list for them, and it says, this is the most interesting vessel. And then they go visit it with guns and masks. I interviewed them. They were comparing it to their prior system, and I asked them, how often is the one on the G2 side better? And they looked at me and just went, 100%, which is cool. Okay. This is, I think, the only thing I say about what I'm doing right now, but I talked IBM into a beautiful partnership and spin-out, and it's one of a kind. They've never tried this. I walked out the door as one of 70 IBM fellows, and I have a license to the code. I got my team. We have a patent cross-license, and it's super exciting, and yeah. So anyway, but it's an experiment. And I do a lot of work in the privacy community, so I have some charts on that coming, I do think. But one of the privacy by design points I've got is we send people software, and no data flows to us. No private data. So no one's going to come back and wonder if we stole it or misused it. And I will just say, finally, the really good entity resolution software out there that can do some of the stuff on that slow motion entity resolution, they're all $1 million minimum. It's only for the elite. If you're not the biggest governments. And I've been thinking about, since I've been dedicating my life to this, is what about the nonprofit that's got 8,000 records? What are they going to do? And so my purpose of my company is to democratize it. So the elites can have it too, but nonprofits can download it and run 10,000 records for free. Or I clean up my own address book. Like I export my Microsoft Outlook address book to CSV, and then I just find all the duplicates, like in 3 minutes. I'm like, yay. So it serves very trivial, and it saves Earth. Okay. These are some of the common kinds of places entity resolution gets used. Any entity resolution engine. I did a little drill down on financial services, but just so you can get a taste of that, I don't know if you can read that, but some organizations want to get golden records together. They want to understand their customers' journeys through the bank, but it's coming in across many channels. So they want to combine the channels and see their pathways through the bank. There's something called Know Your Customer. What a bank will do is they'll do a process to know your customer, and then they'll never or rarely look back. So you can do continuous Know Your Customer. And on any given day, as new data lands, if 6 pulled in from 8, it'd be like, hey, whether it's 10 minutes or 10 days later. I don't know. That seems boring suddenly. Next chart. That kind of seems boring too. I originally thought when I spun out, we were just going to provide a toolkit for programmers so they can just compile it in. I don't know how many of you are like technical, but those are special words for you. And then I realized if we didn't have a very simple user interface for the rest of the world, it wouldn't help everybody. So we built this recently, and it calls the fancy thing that we spend a bazillion dollars on. And by the way, that's where you go. You like free download, and you get Windows or Mac. And then I'm going to give you a quick demo of it, just so you can see entity resolution. But I don't know if the screen is going to look good enough. Oh, you're not going to get any joy out of this. I will flap my hands and tell you what you're missing. Oh, that's amazing. That's amazing too. Oh, that's even more amazing. But if I were to demo this, this is real data. These are 3 restaurant files. Our customer of this does location-based services. So when you're on your phone and you say Italian restaurants near here, like where do they get all the Italian restaurants? Well, they have to go buy files of restaurants. So they go buy file 1 from this company and file 2 from that company and file 3 from this one. But guess what? Data's dirty. There's duplicates in this one, duplicates in that one, duplicates in this one, and then there's a ton of duplicates across them. But maybe this file's got the best latitude, longitude, this one's got the best picture. So they're trying to get kind of a single view to serve you up restaurants near here. Ta-da! You can kind of see this. It says in restaurant file 1, there's 133 duplicates, and it lists them. These are duplicates, duplicates, duplicates. There's 178 possible, and these are possibly related. They share a phone number or share an email. Now, I know you can't see it. Sorry. Here, I changed it from restaurant 1, and I'm now comparing. I left that the same, but I changed this side over here to from nothing to restaurant file 3. So it says there's the 133 duplicates, whatever, 101 duplicates there, 92 duplicates here, and there's 1,600 duplicates in between. And here's this list of them. And then here's the possibles. And I think, so you're not going to be able to see this. Oh, man, you're going to miss the joy. This is super cruddy addresses. Like this one's got 2 postal codes. This one's got 1. This says ST. This one probably says street. The phone number's got a space in it and a +65. Here's like more, ooh, messy address. Here, the names, this is like BWB for like burger, wings, burgers. And so all these different names are collecting together here. Ooh, ah. Now I'm going to talk a little bit more particularly, the first time I've ever presented these charts, by the way. If you see any typos, let me know. I'm going to start with some of the problems, gaping problems that the machine learning industry is facing. One problem is labeled data. When Google did the kitty cat thing, they had 80 million pictures that were labeled. Most organizations don't have that much labeled data. Tough. Very large data sets are required for effective, wait, that's the one I just said. Labeled, oh yeah, this is labeled, and then it has to have a lot of them. So this is, they have to say kitty cat, this is you have to have 80 million. Think of that as deep data. Model resilience. If you didn't train the model that sometimes Passport is NA, like because it's junk, if you didn't train it and NA starts showing up, a great example of this, by the way, is, this is an example of that, this is from an academic paper. That's a picture of a bus. It looks a little better than that with better pixelation. And if you change a few pixels, so it still looks like a bus. I'm telling you, if you can see this in really high quality, it looks the same. The machine will tell you it's an ostrich. Yeah. Yep. And then you can, that's a little hen, and you change a couple pixels, exactly the same picture. It's still an ostrich. And here's a beautiful, maybe Indian temple, and you change a few pixels, and it's an ostrich. That's like a problem. Okay, and these you fidget around like that, and it thinks it's a. You can turn it into a robin, a cheetah, whatever. Okay. Okay, so that was this one. New domains require retraining. So if you start with existing machine learning methods, or the popular new ones, the neural net stuff, if you train it on U.S. people data, forget it. Trying to run it on Singapore companies or vessels. Yeah. You can't explain it. Hence the little pixel move. And they run. You have to run them in batch. So maybe 7 or 8 families move from Somalia to this small little town in a community. Well, all your models are wrong, and it messes them all up. And then every year you retrain it. Okay, what chart's next? Oh gosh, fascinating. The same one. Okay, I got inspired by a magazine story in Wired about machine learning is lacking common sense. And I had this revelation just 3 months ago that this is really the best way to explain what we did that's different. Over here, it's going to be real-time learning, and I'll tell you about that in a second. But I'm going to start with common sense over here. We put principles in and say things like passport numbers are decent identifiers. And we put in principles like if you have the same name and the same identifier, it's probably the same person. And then we have advanced knowledge built in. Why wait for a machine to learn that Rob, Robert, Robbie, Bob are all the same? Like, why? Similarly, the bin and the Hajj, and similarly, if you can connect to a large global standardized address base, you can automatically know those addresses are the same place. So that's common sense. So that's why it works on 2 records out of the box. Doesn't have to be trained. But then after that, real-time learning starts. 3 kinds of learning. Entity-centric learning. You learn that Bob also has the nickname Andy. The moment you learn that, it's very local. You're like, hey, are there any other Bobs at the same address who actually the name's Andy? Because it's really the one guy. So that's local learning. Anomaly detection. You've told it that passport numbers are decent identifiers, but suddenly passport number 1, 2, 3, 4, 5, 6 is used by 500 people. Well, that's something wrong with that one. The moment you learned that, you would want the system to stop making that decision. It's like overriding common sense. And so with those 2 kinds of learning, there's some other learning, but these are the primary ones. Then the sequence neutrality kicks in. It goes, well, if I just learned Bob also goes by Andy, and the passport number 1, 2, 3, 4, 5 is used by lots of people, it's not a good thing to pin people together on. Then the self-correcting goes, first of all, it never makes the mistake again, but it goes backwards in time and looks at all the previous data and fixes the past. And that's like really deep, distant learning because it goes through everything. It's optimized, but yeah. Ta-da. Okay. So now to contrast, this type of AI that we built just for entity resolution, you don't have to label anything. You don't have to tell it what are good matches or bad matches. It works on 2 records. When new things show up like bogus passport numbers, it self-fixes and notices them. You can go from US people to Singapore companies. We got a call one day from somebody and they said, we want to do companies in China. I'm like, what? And they said, we get vendor lists from the biggest global brands. And there's our messy vendor list. But then we scrape the web for toxic spills and child labor around the world in manufacturers because we want to entity resolve it. So we can go tell these brands, why are you letting them make your pillows? It's going to jeopardize your brand integrity. Without any tuning or training, I just sent it to them, and 2 days later they called back and said they canceled all their entity resolution work. It was better than their human. They didn't even think the humans could do it that good. I was surprised myself. It's much easier to explain when you have principles operating this way, and then you can do it in real time, as I was mentioning. So again, my only claim here is that in the area of entity resolution is where my work is applicable. I just mentioned quickly, I've been really engaged with the privacy community. I sit on a board of an organization called EPIC in Washington, D.C. We sue the government for spying. My software also gets used by governments to find bad people, so I'm a bit straddled, but I enjoy thinking about how to bake privacy in, and we started with that in the beginning. So here's some examples. Full attribution means every single record knows where it came from. A creepy story about privacy is a long time ago, right after 9/11, I was helping a government agency in the US with some watch lists, and they had a watch list. It wasn't a long list, but they had a watch list with names on it, but they didn't know who gave it to them. Like, you didn't even know why. Like, bad or super bad? And is it still true? I don't know. Well, that absolutely violates the Universal Declaration of Human Rights. There's 4 articles in there that talk about arbitrary, and one of them, I think 9, says thou shalt not arbitrarily, hoods, masks, exile, torture, whatever. Well, how can it be not arbitrary if you don't know who gave it to you? So our engine requires attribution. Every single record knows where it came from. Favoring the false negative. You only put it together when you're sure, otherwise you can harm the wrong person. Self-correcting false positives is when the senior showed up and it pulled out the very rare false positive. Data tethering says, if your name ends up in a watch list because it's messed up or it times out, like you're forgiven, and somebody deletes it out of a watch list, how long do you think you should have to wait before it makes its way down to the other systems and you're left alone? Like, what, a month? Days? So anyway, data tethering allows you to do that in real time. And selective field hashing allows you to anonymize fields like driver's license and date of birth, so it's non-human readable and non-reversible. And doing entity resolution on that. And I have an example of this from my voter registration project. Okay, I'm taking a short break. All right, I'm alive. We have this big problem in voter registration. Someone will have registered in one state, in Maryland, but they move to Virginia, but nobody remembers to go back to the state where they left and deleted. So later you go look at the Virginia voter list, and there's a lot of voters there that don't even live there. And there's not enough information there to match them. You'd need real entity resolution with another record, like this Department of Motor Vehicle record. Now that you've got all three records, you can then send a note to Maryland and says they don't just take them off the list, they might belong on the list for state elections because they own property, but not federal elections. So they send a recommendation back to Maryland and says, you might want to ask them if they moved. But selective anonymization, before the states send their data, I don't know if you can see it, in the US, name and address are public record. Everybody can see it, so you don't need to hide it. But the date of birth, the driver's license, and the social are not. And so they get hashed at the state before they're sent. And then they get sent to this ERIC organization, and they hash it again with something called a secret key. We're not going to get into this. It gets blah, blah, blah. It gets too deep. But anyway, the benefit is if somebody were to steal their database, they don't have a lot of apologizing to do. Oh, yeah. Now I remember. Oh, I'm closing in on my done part. Okay. I've only shown this next couple of charts a couple of times. I do this because I didn't have a segue. So my segue thing becomes a segue. Hey, don't mock me. I have an advisor, and my advisor's like, you need to think about how the arc of entity resolution is advancing mankind. I'm like, oh, such a big thought. He's a futurist. And now I'm going to propose. I'm going to start with this. This is a drug called Vioxx. It killed, I don't know what it says, 20,000, 30,000, some big number of people. Because it got out on the market, it took 5 years before people noticed. It caused quite a bit of harm. And the problem is, this is unlabeled data. No one would have found it because if you have this prescription data, Vioxx, and you have this dead people data, if you just put machines on this, it's not going to figure out Vioxx is killing people. And if you just look at this, it's not going to figure out Vioxx is killing people. But if you entity resolve it, I have a picture of that. If you entity resolve those two records, you get that, so it labels it puts like the death on the same record. Very simple machine learning from the 1800s now, I exaggerate, can make some claims about that would be a drug that would be more interesting to look at, not wait till 27,000 people are dead. So with that in mind, I'm going to show you this. Okay, I really love to have you challenge me on this because I've really not shown a lot of people this. Bear with me. How much data is there recorded? You know, cave art. One group over there, they use the word water this way, and somebody else uses the word water that way. It's synonyms. Entity resolution is just synonyms about identity. And then there's hieroglyphics, and then there's illuminated manuscripts, and then the Gutenberg press, and then there's not the scale. But, you know, this is the amount of recorded data. And the question is how much have we, and from this recorded data we have a current base of knowledge. But I would argue that there's a difference between the data what do we know from the data that's collected, but what if we could organize the data that's already been collected? Like that Vioxx was entirely discoverable. What about what's left in here? How big is that? And as this is growing, I think this is huge. There's Vioxx, there's, one of the social media sites comes out and says, hey, we found 500 million fakes, got rid of them. It's not like they just showed up yesterday. They've been there a while. But how many things are in there? I mean, is there cures to cancer? What about the mold that kills 30% of the world's crops? How are these people going to find each other? And how do we transition from there to there over the data we've already collected? And there's lots of things people have to be able to share. You have to be able to pull information out of the information. You've got to align it so it's kind of organized. One of the things you have to be able to do is figure out who's who and who's related to who. Or is it the same asteroid or not the same asteroid or the same company? You've got to be able to graph it and see how it's related. You've got to be able to, anyway, this isn't an exhaustive list. It's just like stuff. But the main point is, I think there's a series of things of advances to be done here that are going to take what's already knowable, not new information, known, and advance it and do really significant things. So I'm hopeful of that. Okay.